All right, let's look at number 4 from your homework. If two cards are selected at random, find these probabilities. Here it says fractions or as decimals rounded to 3 places. So I'll just do fractions. This is a fun one. Both are the same suit. So it's one fraction times another. But it doesn't matter what the first draw is. You can draw any card. So it's like 1 over 1, since I drew a fraction. But it doesn't matter what the first card is. You can draw a heart, a diamond, a club, or a spade. It's just that the next fraction is your probability here. So, you could also think about it as 52 over 52. But either way, it's just 1 times, and now there are 51 cards in the deck. So you draw the ace of clubs. Now there are 51 cards in the deck. How many clubs are left? You drew 1, so there are now 12. And 12 over 51, we can reduce that. And we get 4 over 17. So the first card that you draw can be anything, and then you multiply it times the number of that suit remaining, which will now be 12, out of the total number of cards, which is now 51. Because this was without replacement. And if it's without replacement, then it is a dependent problem. In dependent problems, your first event affects the outcome of your next event. In this case, drawing a second card. Both are jacks. This is easier to understand. There are 4 jacks in a deck of cards. So your question will be both are whatever. I guess the fractions will work out the same way for your number 4. So 4 out of 52, in this case jacks, without replacement because both are jacks. So there are now 51 cards in the deck. And we have 3 jacks remaining. And so you could just put this in the calculator. I always put my fractions in parentheses. And we can actually go straight to math, enter. And we get 1 out of 121. I'm sorry, 221. That's why it's so exciting in poker to get dealt 2 jacks in Texas Hold'em. It's very rare to get 2 of the same card, drawing twice in a row. So now both are face cards. This might be something you want to write down if you're not that familiar with cards. There are 12 face cards in a deck. The Jack, Queen, and King. 3 of them, 4 suits. 3 times 4 gives us 12. So the first draw, we have 12 face cards in the deck out of a total of 52. Times, and now for the second draw, again without replacement, these are dependent. So now the denominator is 51. And there are 11 face cards. And I won't make you watch me type it in the calculator every time, because this becomes 11 out of 221. Let's move on. Number 5. We got a bag of marbles. 5 red, 9 white, 7 blue. So how many total do we have? 9 plus 5 is 14, plus 21, plus 7 is 21 total. So, find these probabilities. Randomly choose 2 marbles, 1 at a time, without replacement. So it tells us explicitly, without replacement. So the first one will be red, the second one will be white. That's our first probability. We're out of 21. How many red are there? It gives us 5 red. And then we multiply this. And again, without replacement means that these are dependent, so our denominator changes. There are now 20 marbles in the bag, but we did not affect the number of white marbles. That is still the number given to us, which is 9. And so, I haven't worked this one out, so I'll put it in the calculator. 5 over 21 times 9 over 20. There's our decimal. And math enter, enter. I get 3 over 28. Oh, I'm sorry, it asks for decimals. Decimal to 3 places. So, let's make sure we know our rounding. We get 0.10, and then to the third place, we look to the number to the right. If it's 5 or above, we bump up this third number. But it's a 1, so it remains a 7. Probability that both are the same color. Ooh, do I remember how to do this one? So for the first draw, I think you have to do all 3 of them. Let me work this out real quick. Hold on. All right. So, I do remember how to work these out. Just wanted to make sure. These are kind of tricky, these next 2 probabilities. But they're fun problems, so let's talk about them. The probability that both are the same color. So, the probability that both are the same color, we have to consider, the probability that they're both red, and then we'll add that to the probability that they're both white, and add that to the probability that they're both blue. And that's how you work out this problem. So, for red marbles, it's 5 out of 21 times. Again, we're drawing 2 marbles. It's like there's 3 different scenarios here that we consider. And then it's the sum of them. So, the probability that they're both the same color, well, they can both be red, and that probability is 5 out of 21 times 4 out of 20. Because the probability changes, because they're both red. And then the probability that they're both white, in this case, it's 9 white marbles out of a total of 21. So for the second draw, it would be 8 out of 21. And then for blue, there are 7 marbles given at the problem here. So 7 out of 21 times, and then it would be 6 out of 20. So however many red, white, and blue marbles you have, those would be your numerators. Whatever your total is going to decrease by 1. Whoops. Glad I said that. The denominator is going to decrease by 1 every time. And then you just put this in the calculator. And my calculator is dying, so I won't use it too much. But you can open put all of this inside one big parenthesis. So I open a parenthesis, and then I do a parenthesis for 5 over 21. Close that. Multiply it by, open a parenthesis for 4 over 20. Close the parenthesis for that fraction. Close the parenthesis that I opened at the beginning. And I hit plus. So this is like a long one to put in the calculator, but this is how I did it. Open up parenthesis for this little chain right here, and then in parentheses 9 over 21. Close, and then open to multiply it to 8 over 20. Close the parenthesis for that fraction, close the parenthesis for this chain. And don't forget to add, you need your plus sign, and then 7 over 21 times 6 over 20. I hope I didn't miss anything. And that's the right answer. So to 3 decimal places, 0.319. So you could also take these one at a time. 5 over 21 times 4 over 20. And you could just write down, what this becomes. So 0.046 or 47619. You could go out a few extra decimal places if you're going to do what they call intermittent rounding, rounding the steps as you go. But if you don't want to put all of that in the calculator in one long string, you can find out what each probability is and then just add them. So you could do that for that one, add it to that one. Either way will get you to the right answer, which in this case is 0.319. And then the next one is fun too. The probability that the second marble is red. And so again, I kind of think about it like we have 2 different scenarios. And the 2 scenarios are, again, we're looking at the probability that the second marble drawn is red. So the 2 scenarios are that the first marble is red. And then we will add that probability to the second scenario, which is that the first draw isn't red. So, in this case, there are 5 red marbles. There are 21 total. Your numbers will be different, but that's what I have here. So, what is the probability that the first draw is red? Well, that would be 5 out of 21. And then we're drawing 2 marbles in a row because it's the probability that the second marble is red. And so then that would become 4 out of 20 for the second event. So we find out what that is, and then we add it to the probability of our second scenario. And so again, if I have 21 total marbles and 5 are red, we consider the scenario that the first draw is something other than red, and then multiply it times the probability that the second marble is red. So, 21 minus 5 is 16. So in my question, I have 21 total marbles, 5 are red. So the probability that the first draw is not red is 16 out of 21. Times, and maybe this is kind of confusing, but it's asking us about the second marble being red. And so, what is the probability that we have a red marble drawn for the second draw? Well, we drew something other than red, so we have 5 red marbles in the bag. But we took out one of the marbles. It was either white or blue, so we now have 20 marbles in the bag. And so, I'll see if I can put this in the calculator. 5 out of 21 times 4 out of 20. And this is what I was talking about with these arrows here. We could call that 0.047619. I'll just go out a few extra decimal places. And then we take 16 out of 21, multiply that to 5 out of 20, and I get 0.190476. And we'll just add these together. So 0.47619 plus 0.190476. And I get 0.238095. And the answer is indeed 0.238. So that's how you can do it if you don't want to put one long string in the calculator. Let's see what else we have. Question 6. A gathering consisting of 7 men and 18 women, at a gathering consisting of 7 men and 18 women, 2 door prizes are awarded. Find the probability that both prizes are won by men. The winning ticket is not replaced, so we're changing our denominator. Enter your answer as a fraction or a decimal to 3 places. So, both prizes won by men. We have 7 men out of, and then what's our total here? We just add 7 and 18 to get 25. So the probability that the first prize is won by a man is 7 out of 25. And then we multiply that to 6 out of 24. Yes, you can't win, one person can't win twice. I was looking for that in the question, but it's about winning tickets. So we do 7 out of 25 times 6 out of 24, and I get 0.07. And students get a little confused maybe if it says to do 3 decimal places, but it ends at 0.07. This is what's called a terminating decimal. And so that's just where the number ends. You can't, you could put a 0, but you don't. I wouldn't do that. Of course, you could also make that a fraction, which is 7 out of 100. And then, part B, is it likely or unlikely that at least one of the door prizes isn't won by a man? It's kind of a weird way to ask it, but it's saying, is it likely or unlikely that at least one of the door prizes is won by a woman? And in this case, yes, for sure. Because out of the total of 25, 18 of them are women. So, it is definitely likely that this event will occur. Let's do one more. Number 7. A survey of 500 college students, so it gives us the total, shows the average number of minutes that people talk on their cell phones each month. Round your answer to at least 4 decimal places. If a person is selected at random, find the probability that the person talked less than 600 minutes if it is known that the person was a man. So in math, we call that given. So it's given that we're looking at the men category. And then the probability that they talked less than 600 minutes, that's right here. So 54. And so that's just 54 out of 500, which is 54 divided by 500. And I get 108. Let me see if I did that right. 1 second. All right. My mistake. Again, the fact that it is given that the person was a man, my mistake was my total was wrong. The number 500 includes all of the women here. It is given that the person selected is a man. And so we add here. And we get 93. But 54 plus 19 plus 14 plus 6 is 93. And I'll go over here. When I do 54 out of 93, then I get to 4 decimal places. 0.5806. This does not go up. So 0.5806 is our answer. So again, it will be given that you're choosing from one of these populations, the men or women. And so this was my mistake right here. So it's given that it's from the category of men, and so we find that sum, and then it's the less than 600 out of 93. So I'll stop this video here.